let's discuss sketching linear graphs. Now, when you sketch a linear graph, you'll use 2 points to draw the line. So when you were plotting, you had to use, all the points. So you had a table of values and you had to find all the coordinate points, and then you had to plot all of them on the graph and then do the line on those points. Whereas with a sketch, a sketch implies it's not quite as precise. You just use 2 points to draw that line. So there's 2 methods that we use. The first method is the x and y intercept method. So the x-intercept and y-intercept method. Now I have to admit that this is the method that I use the vast majority of the time, if not all the time. Why? So we use the location of the x and y intercepts to give us our 2 points. So our 2 points that we use to sketch the graph are the location of the x and y intercepts. Now, these 2 points are very important points to know in any graph. So usually when we're sketching any type of graph, be it, our linear graph, our quadratic, our, just parabola, a cubic. So, we've got our linear graph, quadratic, which is parabola, our cubic, our quadratic, it's not quadratic, our quartile, sorry. Knowing those intercepts are hugely important. So usually I would use this type of method because we need to find those points anyway. So I have to admit I'm a bit biased in terms of my my methods that I use to sketch a graph. Now, it's important to remember that our x-intercept is found where y equals 0, because our x-intercept occurs where y equals 0. So we've got our y and our x. So that's our x-intercept. Now, thinking about our y, that is where y is 0, because everywhere along the x-axis, y is equal to 0. And so our y-intercept occurs where x equals 0. So that's our y-intercept. And x equals 0 everywhere along that y-axis. Okay, so let's do some examples. So I've got 2y minus 3x equals to 6. All right, so let's find our intercepts. So I'm going to make x equal to 0. So I'm going to sub that into the equation. So 2y minus 3x. Now x is equal to 0, so that's minus 0. So I don't need to write that in. Equals to 6. So I solve for y. So I divide both sides by 2. So y equals to 3. So my y-intercept occurs where x equals 0 and y equals 3. Okay, to find my x-intercept, I might just write y-intercept up there. X-intercept. Our x-intercept occurs where x equals to 0. So I sub that into the equation. So 2y when y is equal to 0 is 0. So that's negative 3x equals to 6. So then I've got to divide both sides by -3 to solve for x. So x equals to -2. All right. So that means my x-intercept is at -2, 0. So now I'm going to have to sketch this. Now, one reason why I prefer sketching as opposed to plotting is that you don't have to be quite as precise with your scale and so forth. Now, it is much easier when you have a ruler, and of course all of you are drawing this with a ruler. But it would look something like this, where that is equal to 0, 3. That point is equal to -2, 0. And our equation is 2y minus 3x equals to 6. Okay, so now we have one in our general form. But I do exactly the same method. To find the x-intercept, I make y equal to 0, and then I solve for x. Okay, so 0 equals 3x minus 6. So I'll add 6 to both sides, equal to 3x. So that's 2 is equal to x because I divided both sides by 3. So my x-intercept occurs at 2, 0. Now for my y-intercept, you'll probably remember it's just that part there. But I'll go through it here. When we're subbing x equal to 0, y equals, well, that's 0 minus 6, so y equals -6. So my y-intercept occurs where x equals 0, y equals -6. Okay. And let's sketch this. Y, x. Remember, you must always label your axes and put arrows at the end. And it would look something like that. Okay, so that's 2. No, it's 0, -6, and there's 2, 0. Okay, so here I've got y equals -x. Alright, so first off, let's think about our x-intercept. X-intercept. So make y equal to 0. That implies 0 equals -2x. Dividing both sides by -2, got 0 there. So our x-intercept occurs at 0, 0, which is the origin. Now also here, we haven't got a c part here, so that means that's 0. So our y-intercept is also at 0. Now you're probably thinking, okay, that's the same point. We need 2 points there. You said that before, miss. Well, what you can do is just pick any value of x. It doesn't matter what it is. Pick any value of x and sub it into there to get that point. So I might sub in, to make life easy, x equals to 1. Okay. So that means y equals to -2. So when x equals to 1, y equals -2. All right, so sketching this, got y, x. Okay, so I've got a point at the origin, a point at 1, -2, and then I draw the line through those 2 points, like so. And I'll mark that in. Alright, so we've got y equals half x plus 4. So we know our y-intercept will be at y equals 4. So that's our coordinate 0, 4. Our x-intercept is where y equals to 0. So we substitute that into the equation. Equals half x plus 4. So I'll take 4 from both sides. Then I have to divide both sides by a half. So -4 divided by a half is -8. So drawing this up, okay, y, x, and we'll have point here, point roughly there, and so that's at 0, 4, -8, 0. Now I hope you're noticing that the difference that sign is making. Our slope, that's saying what direction our slope is. That is a negative slope, because remember we always read our graphs from left to right. That's a positive slope. So here we're going to have another negative slope. So my y-intercept, x equals, we know when x equals 0, y equals to 9. So that's at 0, 9. Okay, so now we have to find our x-intercept. So that's when y equals to 0. So we sub that into the equation. So 0 equals -3x plus 9. Now I might add 3x to both sides. And then divide both sides by 3. So my x-intercept occurs at 3, 0. Okay, so let's sketch this up. So the good thing is you should be able to start to guess what graphs will look like before you even start sketching, because that tells you if it's positive or negative slope, and that tells you your y-intercept. So we have a negative slope here, negative gradient. So 9, 3, like so. So that point is at 0, 9. That point is at 3, 0. We always marking any important points with the coordinate. Right, so the other method is the gradient and y-intercept method. So we have to know the gradient and the y-intercept in order to use this method. So if you're given an equation in the general form, you know the gradient and the y-intercept already. Now, one other thing is that it's very important to have an accurately scaled set of axes, okay? You have to be accurate with it. So let's go through these examples. So we have here y equals 3 over 2x minus 1. So our gradient or slope is 3 over 2. Our y-intercept is at 0, negative 1. Okay, so this gives us our first point. Now our gradient or slope helps us to get to the second point. So let's draw this up. Okay. Didn't draw that one very well, but I can't use a ruler on the iPad. Okay, y, x. So let's start putting some things, our scaling. Negative 1, negative 2, 1, 2. So 1, 2, 3, 1, negative 1, negative 2, negative 3. Okay, so my first point is at 0, negative 1, which is here. Now, to get to my second point, I have to look at my gradient and go, okay, so it's rise over run. So go up 3 and across 2. So go up 3, 1, 2, 3, and across 2, 1, 2. And then we draw the line between them. Okay, so that is y equals 3 on 2x minus 1. So you can see how you need to have an accurate scale on here for your graph to really truly make sense and for you to be able to show that slope. Okay, so here you have to remember that the slope or gradient is rise over run. So we go up 3 and across 2. So here I've got y equals negative half x plus 1. So my y-intercept is equal to 0, 1. And my gradient is equal to negative 1/2. So let's sketch this up. Y x, okay. 2, 1, negative 1, 2, 1, 2, 1, 2, negative. Okay, so I start off at my y-intercept, which is 0, 1, and then I have to go 1 down across 2. So the negative is in the rise, okay? So whereas up here, I went 3 up, here, because of that negative, it is telling me 1 down, 1 down, and across 2. Well, that was a bit skew-whiff, wasn't it? And this is why, whenever you're drawing graphs, you must draw them in pencil. -1/2 x plus 1. Let's do another one. Okay, so y equals 2x minus 3. Well, my y-intercept is at 0, -3. Remembering that that sign there is the whole thing is our c value. Now, our gradient is 2. Now, you're probably thinking, but we've got to do rise over run. What does that mean, 2? Well, you've got to think, well, how would we write 2 as a fraction? 2 as a fraction is 2 over 1, isn't it? 2 divided by 1 is 2. So we go up 2 and across 1. Our rise of 2 and our run of 1. So let's sketch this. Okay. X, Y. Okay. So I'll put our scale on. 1, 2, 3, -2, -3, and I've got my first point there, and we go up 2, 1, 2, and across 1 to get here. Now, usually in any question, we would also ask you to label our x-intercept and our y-intercept. So that's why I tend to use the x and y-intercept method, because we have to find them anyway, and because then I don't have to be quite so accurate, because I'm not very good at drawing. I fully admit that. Okay, so we've got here y equals 3x over 4 plus 1. So my y-intercept is at 0, 1. And my gradient is equal to. Now you've got to remember that that is the same as 3 over 4 times by x. Okay, it's just been simplified and put all together. So my gradient there, my slope is 3 over 4. So rise of 3 for a run of 4. Let's sketch this. Now, I'm not putting the x-axis exactly in the middle of my y-axis here, because I can look at this and go, okay, I'm starting from +1. I have to go up 3, so I have to make sure that I'm showing plenty of that y-axis. So let's put in our scale. Okay, so 1, 2, 3, 4. Okay, so our first point is at 0, 1. Our next point is 3 up. So a rise of 3, 1, 2, 3. And across 4. 1, 2, 3, 4. And you would be doing this with a ruler, so you could line that up well. So y equals 3x on 4 plus 1. So vertical and horizontal lines. So as you might remember from what we were doing before, when we have a horizontal line, that slope is 0. Also, it only has one axis intercept, the same with vertical lines. So if you did a table of values of your horizontal line, say for example if y equals 2, it doesn't matter what the value of x is, y will always be equal to 2. So you sketch up your axes. Yep. Y, x. Two, 1, and that is y equal to 2. Now for your vertical lines, you'll probably remember that the gradient is undefined. Okay. Here I've got x equals -3. So that means that it doesn't matter what value of y I have, x will always be equal to -3. So I'll sketch that up. Up my axis first. Okay, there's x. Oops. And put my scale on. -1, -2, -3, 3, 1, 2, 3, -2, -3, and our graph will look like that. That is x equal to -3.